All right, so I made this lovely video, it lasted 22 minutes, and then discovered that my iPad had turned my microphone off and I didn't realize it. Let me talk about some of the highlights on this, and we'll see if we can kind of go from there, and maybe I don't have to make another video. Anyway, I'm sorry about that. So the first one I see, the base it's log base 10 of something equals log base 10 of something, so we can set the somethings equal. It's quadratic, we factor, we find one of our values is negative, and so I can't plug that in actually to either side, and so there becomes just one solution on that problem. Even though this equation has two solutions, this equation only has one. Okay, so with log equations, you always want to go back and plug it back in and see what happens. The next one, I put the next one in, it's almost identical to the first, but the difference is that both answers do work. So you could have a situation where you get two answers. The third one, this one, I noticed, what did I do? I just had to set the things equal to each other, and it was pretty straightforward. Okay, let me talk about number 4. So on number 4, one option is to do I heart logs. And so I took the initial problem and on the left-hand side and squished it together over here. And then I said, okay, well, 4 to the 1 equals that. Oh, okay, that's kind of messy. But I did I heart logs, came down with something quadratic, checked my answers, and it worked where -2, we think -2 shouldn't work, but when I plug it back in, sure enough, it does. That's option 1. Option 2 would be to say that I can use a funky form of 1. And so if you remember, log base b of b is always equal to 1. Well, what I notice is in this problem, I already have a base of 4 a few places. So I can say, well, log base 4 of 4 is equal to 1, so I can change this 1 to be log base 4 of 4. Okay, so that's what happened on that one. And, okay, the next one, that got squished, this subtraction right here got squished together with division. Subtraction got squished together with division. They had the same log of the same base. I could set them equal, and then I solved. So pause a moment, make sure you understand what's happening. Okay, the next one, number 6, is very similar to those previous two. Keep in mind, I can't take the log of 0, so I have to, the domain of a log function, domain of log of x is going to go from 0 to infinity, but it does not include 0. So be aware of that, and that's why that 0 doesn't work on number 6. Number 7, okay, so the option with number 7 is either to option 1, I can take the log of both sides and then use my properties to move that exponent out front and then divide. Or I can say, well, this is in exponential form, let's move it to logarithmic form. And so I did, and if you remember, the change of base property allows me, oops, well, that was fun. Okay, the change of base property allows me to say that log base 3 of 5 is equal to log base anything of 5 divided by log base that same anything of 3. And so those two things are equivalent. The next one, what I see here, when I see that e, I know that the natural log of x has an understood base of e. So if I take the natural log of e, those bases cancel, that's just equal to 1. So I come along here, well, so if I have the natural log of e to the negative x over 3, then this just becomes, well, it's not equal to 1 anymore, I don't really know what it's equal to. I just have negative x over, I mean, I could look and see. X over 3 would equal the natural log of, well, this divided right here to 5. It's nice and lovely. There's that. That's great. So notice that my goal in this one was to get x. So I'm trying to get x by itself. The first thing I got rid of was that 3.4. Then the next thing I did is got rid of, I took the natural log, so it wouldn't be in the exponent anymore. Anyway, that was kind of the rationale on that one. Number 9 is almost identical to that. Number 10 is where it gets a little bit more interesting. Okay, so hopefully you saw that I posted a video that I made 3 years ago. So you definitely want to watch it because the calculator trick on this problem right here is brilliant. Okay, you need to, it's not a calculator trick, but the calculator strategy, the method I use to check my work, is definitely something you want to make sure you know how to do. Another video, this one I don't have in the examples, but I did put in the practice. So add this to your notes and then go watch that other video. This one right here is an easier version of this one. So I'm not actually going to talk through it. I'm going to make you go watch the video. Because I'm not a nice person. Okay, then this one, the third one from that old video is pretty similar to what we saw before, but if you want to watch it, no more power to you. The last one is a little bit different. It's kind of clever, so enjoy. There is one problem where I said something like 4 to the x, hang on, let me think if I can come up with a good one, minus 4 times 2 to the x equals 0. If you have something like this, and that looks, here's the trick on that. This is a great one for, this behaves in a similar way to this guy, but it looks pretty different. So let me talk about this one real fast. I know that 4 to the x is equal to 2 squared to the x, which I could rewrite as, because 4 is 2 squared, I could rewrite that as 2 to the 2x, or I could write that as 2 to the x squared. So what I see here is I can say, well, this is 2 to the x squared minus 4 times 2 to the x is equal to 0. We can do a u substitution, not a me substitution, but a u substitution. Oh, okay, it's still funny. This becomes u squared minus 4u is equal to 0. I can factor out the u. And now I find that u equals 0 or u equals 4. They didn't ask me to solve for u, they asked me to solve for x. So this is 2 to the x equals 0. Well, that's no good. So what I like to say here is nothing to see here, because I can't raise 2 to a power and get 0. Keep in mind there's an asymptote at y equals 0. So, but I don't like to necessarily say that there's no solution, because there might be a solution over here. Well, and this one is 2 to the x equals 4, and sure enough, I did this on purpose, x equals 2. Okay, I'm sorry that previous video had no audio. I don't want to blame myself, but I guess it's my fault for not checking.